Hello. In this module, we'll be talking about additive rule of probabilities. Before we go further, we need to discuss about the two different types of events. Firstly, we'll talk about the mutually exclusive events. Two or more events are said to be mutually exclusive if they do not have any outcomes in common. That is, that these two events cannot occur together at the same time. If A and B are mutually exclusive events, then the joint probability of A and B equals to 0. That is, the probability of A intersection B, that is the joint probability, will be equals to 0. And this could be evident from the following Venn diagram, that there is no joint probability or joint region exists between A and B events. The other type of events are not mutually exclusive events. Not mutually exclusive events are those events that can occur at the same time. If A and B are not mutually exclusive events, then the joint probability of A and B existing is non-zero. We can look at from this following Venn diagram that if in this sample space we have two events A and B, then the region of joint occurrence will be called A intersection B, which represents that two events A and B can occur at the same time. Therefore, the additive rule says that if we want to calculate the probability that a person selected will be an early age onset and a later age at onset, here these two events are mutually exclusive events. When a person will either be an early age onset or a person will be either a later age onset. Here, one thing is very important to know in this statement, that we are interested in finding out the probability of an early age onset or later age onset. This refers towards the either and or situation, that either one happens or other happens. So there is this specific rule for mutually exclusive events, for the addition of the events, that if our interest is in the occurrence of either event E or either event L, this will be given as probability of early age onset or later age onset. This OR operator will be represented by the union of two events, which represent the probability of E union L, which is just given by the addition of the two respective probabilities. Since the events are mutually exclusive events, we'll just add the individual probability, and the probability of the joint occurrence will be equals to 0. Hence, the probability of E union L will turn out to be the addition of the individual probabilities, and this addition turn out to be 1 in this specific scenario. But this is not always going to be true. This is the only case. This is a very specific situation where the probability of the occurrence of either of these two events turn out to be 1, but it's not always going to be the case. Therefore, let's take another example for mutually exclusive events. In this example, let's use the additive rule to predict the fraction of offspring from a heterozygous cross that will have the dominant phenotype, that is either capital A or capital A and small a genotype. In this cross, there are three events that can lead to a dominant phenotype. Either it will be two A gametes meet, given AA genotype, or a dominant gamete from mom meets with a recessive gamete from dad, giving capital A small a genotype, or a recessive gamete from mom meets with a dominant gamete from dad, giving AA genotype. So there is this OR in all these three possible events. Let's say we call these three events as event A, event B, and event C. Therefore, the probability for either getting A or B or C will be given as probability of A union B and union C, which will simply be the addition of their individual probabilities. And since we know that each individual event has a probability of occurrence that is 1 by 4, it turned out to be 3 by 4 is the probability for getting this specific event. Look at the additive rule in this Punnett diagram, which also shows the similar situation, where we have 4 possibilities, and out of these 4, there are 3 possibilities where we will get our event of interest. Hence, the probability turn out to be 3/4 for our chance of dominant phenotype. There's this general definition for the additive rule of the probability, that given that we have 2 events A and B, the probability that event A or event B or both occur is equal to the probability that event A occurs plus the probability that event B occurs minus the probability that the event occurs simultaneously, which can be written as probability of A union B. And union is the OR operator over here, will be equals to the probability of A plus probability of B minus probability of A intersection B, where A intersection B is a probability for the joint occurrence of the events. And if the events are mutually exclusive, this probability of A intersection B will be equals to 0. And if they are not mutually exclusive event, then this general form will prevail. So in our example of family history of mood disorders by age group, if we seek to find out the probability that this person selected will be an early age onset subject or will have no family history of mood disorder or both, the probability, since over here there is this joint occurrence of these 2 events, hence we can say that these are not mutually exclusive events. For these not mutually exclusive events, if we want to find out the probability of event E or an event A, we'll write it as probability of E union A. Then probability of E union A will be equals to the probability of E plus probability of A minus the joint probability. It turned out to be 0.5534. Hence, there are 55.34% chances that either a person will be an early onset or will have no family history of mood disorder or both. There are various other rules which are used to calculate the probability of events. There are complementary rules and one of the very famous one, Bayes rule. Thank you.